Hey guys, welcome back. Let's continue with the piston engines. We'll be doing lubrication system. Generally there are two types of them, and that is wet sump or the dry sump. It's also called as the splash system. Other name for wet sump is splash system, and the other name for this is force feed system. Okay, so first we'll discuss wet sump. Wet sump is as easy as it can be. It is just oil is stored. Oil is stored in the crankcase. If you remember, there was a crankcase in the piston engine diagram in the construction that I showed you, something like this, in which the whole piston is placed. So the oil is stored in the crankcase at the bottom of the engine. Okay, and the crankshaft is dipped in this oil. Okay, so the crankshaft is dipped in this oil. So now what happens is when the crankshaft rotates, the oil is splashed. When crankshaft rotates, oil is splashed onto the engine. It's as simple as this. Now this is generally not suitable, any guesses? Suitable for aerobatic or even inline engines, because your maneuvers are reduced, and you cannot do any maneuvers, because if you do maneuver, your oil will be all over the place. Now there are disadvantages to this. Lubrication difficult during maneuvers. Okay. Second, temperature is tough to control. Oil becomes contaminated or even oxidized, for that matter, oxidized easily, because it is generally in the open, and its contamination charges are much higher. So that's about wet sump here, and it's generally not used. It's very used in very few aircraft. Alright, so next I'm gonna discuss is dry sump. For that I have this diagram here. So first I'll explain it to you guys, and then we're gonna go ahead for the written part. I'll explain it to you. So in this, what happens is you have a reservoir right here. Alright, a reservoir is stored. So in that, the crankcase itself was the oil, where oil is stored. Here there's this proper reservoir, and just as it comes out, the oil temperature is measured, what you're gonna supply. While I'll tell you what are the consequences of supplying more than normal temperature oil, or less than normal temperature oil to the engine. So then there's a suction filter that filters out any contaminated particles. Then there's the pressure pump, which has a pressure relief valve. In case the pressure pump gets jammed, it could come through the relief valve. And there's a pressure filter again for the same purposes. Just before, as the oil enters the engine, the pressure is measured through the oil pressure gauge here. And once it is utilized for the lubrication in the pistons and everywhere, it just drops down, and a scavenge pump pulls it out. Okay, scavenge pump pulls it out and sends it through this oil cooler that's in the front, and this is a air cooled engine. Alright, so air will hit the oil that is going through this oil cooler, and it will cool it, and it will send back the oil in the reservoir. This one is the same valve that is used in case this is clogged or jammed. It can just easily bypass and go back into the reservoir. The diagram is fairly simple, and there's this at the top here is a vent. I'll also tell you what vent is used for, breather or vent it is called. So the diagram is fairly simple here, and whenever I'm explaining, you guys can just come back to the video and just go back in the video and just look at the diagram so that you can understand what I'm explaining. Alright, so let's start writing some stuff about it. So this is what is called your dry sump. Okay, oil is stored in a reservoir. Okay, then it goes through, it goes through a filter, pressure pump to the engine. Okay, now reservoir is vented. As I said, reservoir is vented. What's a vent? Now vent is also called as breather. Breather, it is to avoid, it is meant to avoid pressure build up because of the vapors that are there of the fuel. So a pressure might build up inside the reservoir. To vent that out, the vent is used. So this is used to maintain atmospheric pressure and pressure inside the reservoir, and this gives you positive flow to the oil. I think I have discussed a similar concept for the fuel in the previous video as well. Now the oil leaves reservoir where oil temperature is measured. Okay, now this is done, and then it goes to the through the filter where sediments are trapped, just to remove particles. Alright, and then there's a bypass valve as well. Bypass valve from the pressure pump, if you remember, if in case your filter or your pressure pumps gets clogged, the bypass valve is used to give uninterrupted flow. Okay, next okay, so next we have is a pressure relief valve that was there beside the pressure pump. The pressure relief valve ensures steady valve pressure, so that it just takes the surge. If there's excess pressure, the pressure relief valve will take the surge, and if there is less pressure, it will adjust, it will compensate for that pressure change of the oil. Okay, then at the last, when the engine, it goes into the engine, it lubricates it around the piston, everything, keeps the temperature in control. Then what happens is scavenging. Scavenging in general terms literally also means to remove. Alright, so oil is collected in a sump at the bottom, more or less it collects in the bottom, and it is pumped back to the reservoir after passing through a air cooler, as I showed you in the diagram as well. Now let's note some few points here. Scavenging pump capacity is greater than pressure pump. Why? Because we need to scavenge, so need to avoid accumulation of oil in the engine. So the capacity of the scavenging pump, the ability to remove excess of oil as soon as possible from the engine, hence the scavenging pump capacity is always greater than the pressure pump. The oil pressure gauge works on the Bourdon tube principle. Okay, next let's go with another pen. Oil pressure gauge is fitted between the pressure pump and the engine. Okay, because we measure the pressure just before entering into the engine. Oil temperature gauge is fitted as the oil leaves the reservoir. Okay, so that's about this thing. Now I'll discuss what happens during an engine failure, we can call it. What are the criteria if you have a low oil pressure or a high temperature, whatever. So oil temperature, oil temperature. Now what happens if you use a temperature that is lower than recommended oil temperature? We will have higher viscosity and higher pressure. So if it's cool, the oil will be obviously thicker and the pressure will be higher. Alright, so now what happens if it's higher than recommended temperature? It's the opposite, of course, that is lower viscosity. Now what happens with lower viscosity is your lubrication becomes poor lubrication, because it becomes thinner than normal, and your oil just doesn't lubricate the piston at all. It doesn't stick to the piston. And if the temperature, now what happens if the temperature reading in the cockpit is normal, temperature reading is normal, and pressure gauge is not reading correct. Okay, now what happens with this is, in this case what is happening is the relief valve, because if the relief valve is working fine, it would have been, the pressure would have been normal. So if the relief valve is faulty, or your gauge is faulty, because there's a relief valve in the pressure pump, right? So there's no way that the pressure is not proper. If the pressure gauge is not reading correct, either the relief valve is faulty or your gauge is faulty. Okay, because there's some pressure obviously coming to the engine. Next we'll discuss is oil pressure. Now oil pressure higher than recommended. If you use, what will happen if you use higher than recommended pressure? A, you'll damage the pipelines or the pressure lines, whatever. B, loss of engine power and performance. C, increased oil consumption. The engine will struggle to maintain the performance, of course. Then what happens if you have lower than recommended? Lower than recommended will increase heat as less lubrication is happening. Why? Because now your pressure is low, so obviously the your engine will heat up faster, and that's because of your lubrication has reduced. And this, of course, there's no doubt your engine is going to get damaged. Low oil pressure, you have chances of pre-ignition and detonation. Okay. Now when will your when can you expect engine failure? Engine failure will occur when temperature is high and pressure is either normal or low. So that's when your engine will actually struggle to give you performance, and it's more or less that it will fail as well. Okay, let's go to the next. Now there's some small concept called hydrolysing. I'm not sure if you guys have heard, so let's do some small bit on hydrolysing. So that is Hydrolycing. So which kind of engines struggle with hydrolysing is radial and inverted. Generally this problem is found in radial and inverted engines. Now what happens in hydrolysing is, after the engine is shut down, the oil may accumulate between the piston and the cylinder head in the lower cylinder of the engine. If you remember, I had explained some small top concept on radial engine. It is circular, right? So at the bottom there may be some oil that is accumulated between the piston and the cylinder head. So this is called hydrolysing. So after, I'll just write it down so that you can also remember. After shutdown, accumulation of oil in the lower cylinder is called hydrolysing. This is damaging to the cylinder. So how do you get rid of this problem? Is prior to starting on the engine, you rotate the propeller. So rotate the propeller to ensure that there is no hydrolysing occurred, and the oil just moves out of the piston and the cylinder head. Okay, this how does this damage the engine? Now what happen is, when the piston moves in the compression stroke, there's oil trapped in the combustion chamber, so that can be actually damaging. It will ignite. Okay, and generally weight of oil, this is not really a necessary point, but you can just note it down. It depends though. Weight of oil is generally measured in pounds or imperial gallons. Okay, quarts or something of that sort. Alright, now I'll just give you a few points that can help you answer some key questions around if asked. CHT, cylinder head temperature of an air-cooled engine could be controlled by the cowling grills. If you have a good cowling grill going on, your head temperature is kept cool. Controlled by cowling grills. If you have a restrictive cowling grill, your engine is going to heat up soon. Now, air-cooled engines, if you remember, are finned. There are fins on the cylinders to keep give a larger cooling surface to the airflow, and that cools it faster. And the scavenging pump has greater capacity than the pressure pump. I've already told you that. Scavenging pump capacity greater than pressure pump. Very important question, generally asked most of the time. And a relief valve is fitted on the outlet of the pressure pump to prevent excessive pressure being delivered to the engine. If you remember, I told you it relieves the pressure pump in case there's a clogging or any excessive pressure that is not allowing oil to be delivered to the engine. Now another point here is, if your fluctuation is there, fluctuation in the gauge, that is more or less because of relief valve striking. So relief valve striking, if there's a low oil pressure fluctuation, so it is because of the most probable cause is because of the relief valve striking. The oil temperature gauge records the temperature of the oil being delivered to the engine. That's pretty obvious. How is the oil removed? Remember the construction of piston engine I discussed? The oil control ring. Oil control ring removes excess oil from the cylinder walls, and it is fit below. Okay, now another important point here is the viscosity will increase with the temperature dropping. Okay, obvious, right? If your temperature is dropping, it will cool up and it will become thicker. It's not going to move easily, so viscosity will increase, and the rate of flow will also affect. That's because of the viscosity increase. Now, important practical note is, always when you step into the aircraft, do check your oil before getting on, and while you get down, when the engine is stopped, check oil after a short time, because the quantity will vary if on a cooled engine and a hot engine. So check oil after a short time. And CHT measurements are obviously taken from a thermocouple on the hot junction I had already discussed in the previous video. So that's all about lubrication for today, and I hope you guys are understanding and learning a lot from my videos. These are basic stuff actually. If you want to actually go in depth, I would suggest you to go through Oxford, yes. And this I think is good enough for you to understand the basics and fundamentals. Alright, so that's all about today's video, and if you like it, please do share it and also like it as well. Subscribe to the channel, go hit like on the Facebook page, and yes, follow up the quiz. It will be right on the video. There's a quiz on the description link, so that you assess yourself what's happening. This I've introduced recently, so that because a lot of subscribers are asking for it as well. So let's take a short quiz, 10 questions. I think that should be enough for this lesson, and you will know how good you have understood lubrication. And yes, I'm gonna start a new course as well on the Airbus A320 due to a lot of demands in that as well. So I hope you guys will hit that as well. Alright then, see you guys, bye bye, take care.